Alright, hello my wonderful students. This is Foldable 2 of 6, 7 inverses. So we have three different things that we're doing in this one here. We have the first one, we're going to find the domain and the range of the function and its inverse. We're going to, is it an inverse? And we're going to do graphing in an inverse. So we'll go ahead and get started on the first one. So right there. So we have our f of x is equal to the square root of x minus 4. And we're going to find our inverse of f of x. So in order to do that, we're going to go ahead and substitute this for y, just like we normally would. By the way, and this would always happen, by the way, even though this is not x, say if this was L, P, A, N, doesn't really matter. This will always substitute to y. Doesn't matter what it is, it will always substitute to y, because that's what we use as a general form of graphing. So we're going to go ahead and switch the variables. Okay, variables, there's two of them. So we have x is equal to the square root of y minus 4. Now we're going to solve for y. Try to put that, because it's the letter y. To find the inverse. Alright, so in order to do that, we have to get rid of the square root first. So I know the opposite of a square root is a square. So I'm going to go ahead and square both. So I get left with x squared is equal to, these reduce, and leaves me with y minus 4. So I go ahead and add 4 to both sides. And this will reduce, so I'm just going to put y in front. Y is equal to, because this is gone, x squared plus 4. So this is saying that our inverse of f of x is equal to x squared plus 4. Alright, so now we got to find the domain. Domain and the range. And we're going to do that of both. So let's do one in blue. If blue works. So we're going to go ahead and look at our f of x. F of x is equal to our original function, which is this. The square root of x minus 4. So we're looking for the domain and we're looking for the range. Okay, so the domain is going to be based on our x and the range is going to be based on our y, or our f of x here. So I'm going to write domain and then our range. I don't know why I capitalized the range and not the domain. I should either capitalize both or not capitalize either, but I just put a capital D there. Alright, so our domain, I said, is worried about our x. But we see here that this, we have to figure out what makes this not true. So the only thing that can make this not true or not real would be if this was negative inside here. So we have to set this equal to 0. X minus 4 equals 0. And we know that if we add 4 to both sides, we get x is equal to plus 4. So in order for this to be not negative, so 0 or bigger, the domain has to be at least 4. So if you guys remember that lesson when we did at least, it would be x is greater than or equal to 4. Because x cannot be less than 4, or this would be negative, and it won't be real. Okay. The range here has to be equivalent, or has to be what this can produce into here. So we know this is all square rooted, so it cannot be less than 0 as well. How do I explain it? So whatever you get out of here, like what we were saying, you cannot have a negative number cannot come out of here, or it would be imaginary. Same thing that why our domain here, this had to be 4. But this has no restriction of the negative 4. It just says that whatever can come out of here. So our lowest possible thing that can come out, if we put a 4 in here, like we did here, this would be 4 minus 4 would equal 0. The square root of 0 is 0, so this would be x is greater than or equal to 0. Because it doesn't matter what number you put in here that's bigger than 4, it's going to be a number that's going to be bigger than 0. Alright, let's go ahead and do our inverse. Inverse of x, which is equal to what we got here, x squared plus 4. Okay, so we're looking for our domain and range again. All right, so we have to look at this here, and we got to remember that this was from the work up here that we did, this was a principal root. So our principal root, principal root, is that right? I think so. If it's not, I'm sorry guys. That's why I'm a math teacher. So our principal root is always positive. So this is always going to have a positive domain. It's always going to be positive. So our x has to be greater than or equal to 0. So if you don't remember principal roots, remember, go back to the lesson where we did square roots. Where remember, if the square root was given to you, like it was here, then we know we're going to have a principal root. But if the square root is not given to you, then we're going to have both roots. We're going to have the positive, which is our principal root, and our opposite root, which is our negative root. And the same thing with the range. This here, the range here. So if we're plugging in 0 to here for our domain, something 0 or bigger, the smallest thing you can get is 0. So 0 squared plus 4 is going to be 4. So x is going to be greater than or equal to 4. But if you notice, the domain here is the same as the range here, and the range here is the same as domain here. That's because when you have inverses of each other, the domain and range are equivalent, but they swap. So the domain here becomes the range here, and the range here becomes the domain here. That's kind of the biggest thing. So if you can find the domain and range from the original function, then you can just convert it and make the domain and range from the inverse. Just doing it that way.